Hi friends, this is Pragya. Welcome to my channel. We will learn physics, explore so many different unexplored questions and learn new things. For example, today we learn about bicycles. Not learning how to ride a bicycle, but learn about how bicycle works.
No, I'm not talking about riding bicycles. All of us know how to ride one, I hope. In fact, for most of us, it is one of the first vivid memories that we can never forget. But so few of us stop to wonder, why is a bicycle so stable? Come to think of it, a single wheel rope hardly ever travels more than a few meters, and that too very shaky. Even in a bicycle, there have been so many designs out and about ever since the first bicycle was made. But if you notice, basic design of the bicycle is so boringly unchanged, it has to be something more than just a severe lack of imagination.
So it seems like the design of the bicycle is a major factor in its stability. But why really? Like, what is the physics behind it?
Interestingly, bicycle falls under the smaller category of inventions which were happened upon by hidden drivers, like Roda and Jex.
Now, to be very honest, we still don't have a crystal clear explanation of how a bicycle works. But after 2 centuries of scratching our heads, we think we have figured a few things out. Let's see.
The first thing is the gyroscopic effect. For the longest period of time, scientists thought that that was the reason of the enviable stability of the bicycle. You can recognize the gyroscopic effect from the famous totem from the movie Inception. In a sense, it means that any spinning body tends to maintain a steady axis of rotation, and we see this everywhere around us. So it was thought that the bicycle precesses about the steering axis. But when David Jones from Imperial College of London went to test this theory by adding an extra wheel on the front wheel of the bicycle, suspended in air, and expand the wheel in a direction opposite to the direction of spin of the front wheel. Thus, he effectively cancelled the gyroscopic effect. Okay, and the bicycle is still quite stable. So that proves that even though gyroscopic phenomena does play a role, there is so much more at work here. Another factor which seems to be important is the trail, the distance of the projection of the steering axis from the contact point. If this trail is positive, only then will the bicycle be stable. A bicycle with negative trail like this will be extremely unstable. That can be a reason why bicycles are stable when rolled forward or unstable when rolled backwards. David Jones made a bicycle like this UR4 with extended front projection, which was surprisingly stable. The issue with this kind of bicycle is that it's very slow to respond to turning of the handle. So that becomes a problem in everyday life. Another aspect which seems to be important is the relationship between the height of the fork point, the steering angle, and the lean angle. So steering axis first is the axis along which the bicycle is steered. Steering angle alpha is the angle the front wheel makes with the plane of the bicycle. Fork point is the point of intersection of the horizontal line and the steering axis. The height h, the height of the fork point from the ground. The lean angle L is the angle the bicycle makes with the vertical plane. Then, bicycle is stable for all combinations where d square h by dl d alpha is equal to 0.
If you didn't know, now you know. So if you like this, if you like my video, please give it a like. Please subscribe. I intend to load a video every week and share it with your friends. Until next time, bye bye.